Welcome everyone to the study guide review video for the 8th grade Unit 7 quiz on exponent properties. This quiz you're going to take on the computer on Desmos just so you get some more practice with online math tests in preparation for the MCAS, which is on the computer, and the MAP. But you'll have access to scratch paper, and there's definitely some questions that you should be writing things down for. Okay, question 1 is just to summarize the key exponent properties. There's not a question like this on the quiz, but it is like everything you'll need. Like if you know all of these, then you should be able to get every question on the quiz right. So sort of just to have this for reference. So in words, we have that when you multiply powers with the same base, you keep the base and you add the exponents. So like x to the a power times x to the b power is equal to x to the a plus b power, right? And we've seen the reason why that's the case in class lots of times. Then we have when multiplying powers with different bases and the same exponents, we are going to multiply the bases and then keep that common exponent. So algebraically, x to the a power times y to the a power is x times y to the a power. Okay, the group x times y. Then we have when we are dividing powers with the same base, we're going to keep the base and subtract the exponents. So like x to the a power divided by x to the b power is equal to x to the a minus b power. Okay, and order does matter with subtraction, right? It has to be the numerator's exponent minus the denominator's exponent. So that's going to affect whether we have a positive or negative exponent. Then we have when we're raising a power to another power, so like x to the a power raised to the b power, we keep the base and you multiply the exponents. So this is equal to x to the a times b power. Then we know that any base raised to a 0 power, the 0th power is 1. Anything to the 0 power is 1. And then finally a negative exponent, that means the reciprocal of the power with the positive version of that exponent. There we go. So x to the negative a power is equivalent to 1 over, or divided by, x to the positive a power, which is also like 1 over divided by x to the a power. Okay, so you take the reciprocal of the base, it gets flipped to the denominator, or if it's already in the denominator, to the numerator. Cool. Okay, so here's what the quiz questions will look like. 3 of these equations are false and 1 is true. Circle the true equation. Okay, so A is right. We'll go through all of them. But A is right because we are multiplying powers with the same base. So when we do that, we keep the base and we add the exponents. And negative 2 plus 6 is equal to positive 4. We could also write this out, of course. 3 to the negative 2nd power in expanded form is like 1 divided by 3 times 3. And then 3 to the 6th power, we have 6 factors of 3. Okay, and then when we multiply that together, 3 divided by 3 would divide away to be 1. 3 divided by 3 would divide away to be 1. And we're left with 3 4s in the numerator. Okay, so that's correct. You don't have to show work for it, just so you see it now. B is wrong. 18 to the 0 power should be 1. Okay, anything to the 0 power is 1. 3 to the 6th power raised to the 5th power, that is 3 to the 30th power. You multiply the exponents, you have like 6 3s multiplied together, and then you have 5 groups of those 6 3s, so you end up with 33s. And then lastly, basically you need to change, right? 16 to the negative 3rd power is 1 divided by 16 to the positive 3rd power. So it gets at this idea of it being a reciprocal, but when it flips from the numerator to the denominator, then that's the negative exponent is what it's doing, so then the exponent becomes positive. Or you could, that's the way we've more been seeing it, but it's also correct if you flip that to being a positive exponent. Question 3. Select all the expressions that are equal to 15th to the 7th power. Okay, so a lot of right answers here. This one is correct. 15 to the 5th power times 15 to the negative 3rd power. We're multiplying powers with the same base, so we keep the base. We add the exponents, and 10 plus negative 3 is positive 7. The second one is not correct. 5 to the 3rd power times 3 to the 4th power. So we have different exponents and we have different bases. So that is not going to be right, because this means you have 3 factors of 5, then you have 4 factors of 3, and these can join together, and these can join together, and these can join together to get 3 15s that are being multiplied together, but then you just have 1 extra 3 and you're not anywhere close to getting 7 factors of 15. So that's not correct. Third one is 15 to the 7th power to the 1st power. Anything to the 1st power is just like itself, or you can multiply the exponents, and 7 times 1 is 7. So this is just 15 to the 7th power. This one is not correct. 15 to the 70th power divided by 15 to the 10th power is equal to 15 to the 60th power, because we're subtracting those exponents. 10 factors of 15 would divide away to be 1, and we'd be left with 60 factors of 15. And then, this last one is also correct. We have a negative exponent. Again, that tells us let's flip it from the numerator to the denominator, take the reciprocal, so this becomes 15 to the positive 7th power. Cool. All right, question 4. Rewrite each expression using a single exponent. Do not find the value of the expression. So this is pretty much just like straightforward using the rules. 5 to the 8th power divided by 5 to the 2nd power is equal to 5 to the 6th power. You subtract the exponents when you're dividing and you have the same base, or you could write it out in expanded form and you'd see 5 divided by 5 cancels away and 5 divided by 5 cancels away. Okay, same idea for the next one, but we're multiplying. This is going to be equal to 5 to the 10th power. The thing that's tricky about this is when you just have that normal 5 there, you have to recognize that means you have 1 factor of 5. So it's like an imaginary 5 there. So we do 3 plus 1 plus 6, and that's equal to 10. Or again, you could write it out in expanded form, but part of the point of figuring out these rules is so that we don't have to do that every time. And then lastly, we're taking a power to a power. So we multiply the exponents, and where this is going to be equal to 5 to the negative 14th power. We could just leave it like that. It says using a single exponent. So that's actually probably, it's probably the most correct answer, but you could also write this equivalently as 1 divided by 5 to the 14th power. So this is a really small number, like a really small number, like 0.000 something. Cool. Okay. Which expression is not equivalent to 2 to the 3rd power divided by 2 to the 9th power? Show your work. Okay, so 2 to the 3rd divided by 2 to the 9th, we're dividing powers with the same base, so we keep the base and we subtract the exponents. 3 minus 9 is negative 6. So this is equivalent to 2 to the negative 6th power. 2 to the negative 6th power means 1 divided by 2 to the positive 6th power, so that is equivalent to A here. And then if we multiply 2 to the 6th power, so 2 times 2 times 2 times 2 times 2 times 2 times 2, you'll get 64. So B is also equivalent. So thus our correct answer here is D. 1 divided by 2 to the 3rd power isn't the same as 1 divided by 2 to the 6th power. They're getting messed up. They're like dividing these exponents to get 3. So That's their mistake. All right, cool. Question 6. Place a number in each box so that each equation is true and each equation has at least one negative number. So here we are multiplying powers with the same base, and we get 8 to the 0 power. So when we're multiplying powers with the same base, we add the exponents. So we need two numbers that add up to 0 here. Okay. Numbers that sum to 0. And there are infinitely many right answers to this. But numbers that sum to 0 are opposites. So my favorite number is 18, so I would probably do 8 to the 18th power times 8 to the negative 18th power, because 18 plus negative 18 equals 0. Okay, so any pair of of opposite numbers would work. So 7 and negative 7, 15 and negative 15, 2000 and negative 2000, anything like that would work. Cool. And one of these note is a negative, obviously. Okay, next one for B. This one you have to make sure you are putting a negative number in at least one of these boxes. So what I would do is I would just sort of like pick a number for the exponent and then for one of the exponents and then figure out what it's equal to. So what I mean by that is I just said my favorite number is 18, so let's just do that, right? I have 8 to the 3rd power divided by 8 to the 18th power. There I am dividing powers with the same base, so that would be equal to 8 to the 3 minus 18th power, and 3 minus 18 is negative 15. So I get 8 to the negative 15th power, and that's a true equation, and one of the boxes has a negative number in it, so I'm good. And there's other ways to do it, so you just want to make sure yours is correct. If you have something different, you might want to check at home. You could put it in a calculator and confirm you get the same answer. You're not going to be able to do that on the test, but if you did it already and you want to check whether that's right, you can do that. Okay, and then lastly, we have 8 to the negative 2nd power times something to the negative 2nd power equals 24 to the negative 2nd power. There's only one right answer there. It is 3, because 8 times 3 is 24. So here we have to multiply the bases. 8 times 3 equals 24. And the exponents of negative 2 is the same. Cool. All right, question 7. Here are 3 expressions that have the same value. A, 3 to the 4th power times 3 to the 4th power, B, 3 to the 8th power, and C, 9 to the 4th power. Explain how you can tell that these expressions are equivalent. Okay, so what I would do, I would say we can write them all out in expanded form and then simplify. Okay, so 3 to the 4th power times 3 to the 4th power is 4 factors of 3 times 4 factors of 3, okay, which we can then see is 8 factors of 3. Okay, 3 to the 8th power, of course, is 8 factors of 3. So that's equivalent, we can see. And then the last one is the trickier one, 9 to the 4th power. So this means 9 times 9 times 9 times 9. But then what we can do is we can realize that how do we get 9? We get 9 by doing 3 times 3. How do we get 9? We do 3 times 3. So all of those 4 9s can really be split up into 3 times 3. So for all of them, we have 8 factors of 3. Okay, something like that just shows the work or explains it. Cool. 7.2, using one or more exponents, write another expression that has the same value as the ones above and explain how you know the expression has the same value as the others. Okay, so I need to get 3 to the 8th power somehow. Yeah, I'd probably do it by doing division. I'd probably do 3 to the 10th power divided by 3 to the 2nd power. It's not the only way you could do it. It's just would come most easily to me. And then I could write it out in expanded form to explain. So 10 factors of 3 divided by 2 factors of 3, and then 3 divided by 3. These cancel away to be 1. And we are left with 3 to the 8th power. Okay, so that work is good enough explanation. So we have our last question. Precious wrote that 3 to the negative 2nd power divided by 3 to the negative 10th power has the same value as the other expressions. Is this correct? Explain how you know. Okay, so yes, this is correct, and this will be our work to figure it out. So 3 to the negative 2nd power divided by 3 to the negative 10th power. Here we are we're dividing powers with the same base, so we keep the base, we subtract the exponents. Okay, so we have to figure out what is negative 2 minus negative 10. Okay, this is something we learned in 7th grade, but it's tough. So if you are subtracting a negative number, the result is that you're going up, you're taking away something negative, so this turns into like we're adding a positive number. So negative 2 plus 10 is really what we're thinking of here, and negative 2 plus 10 is equal to positive 8. Thus, this is equivalent to 3 to the 8th power. So yeah, it's equivalent. Yeah, I mean, you could write it out in expanded form, but that's going to be pretty tricky because you'll have like fractions and fractions. So just since it says explain, I'll just add a sentence that says, since we're dividing powers with the same base, we keep the base and we subtract the exponents, and negative 2 minus negative 10 is positive 8. Alright, there you have it. Good luck studying, everyone. We're going to review in class a little bit before too on Monday.